Welcome back to Applied Algebra and Trigonometry. Today we'll be talking about Section 9.1, which is Introduction to Vectors. Would it surprise you if I told you that someone could be given a ticket in the village near where I live if they were going 25 miles per hour down a street, specifically Lake Street? There is no school zone on Lake Street. It is designed for vehicular traffic. So if I were driving on Front Street and turned onto Lake Street at a speed of 25 miles per hour, I would receive a ticket. Why? Because Lake Street is a one-way street. Direction matters. Just ask Wrong Way Corrigan. So let's return to my example of driving on Lake Street. Looks like part of my street has disappeared. Just a moment. So when driving on Lake Street, do not head north. Always head south. That is the direction you should travel on Lake Street. All right. Now, south, we already mentioned, is a direction. The 25, as in 25 miles per hour, is a magnitude. It's a measure of the speed at which I was traveling. Okay, 55 miles per hour would be a higher magnitude or a greater magnitude. It's faster. When you have both magnitude and direction, that means that you have a vector. In order to have a vector, you must have two components. You must have magnitude and you must have direction. In this case, the magnitude is 25, the direction is south. If you only have magnitude, you have part of a vector. We call that part a scalar. Okay? The magnitude part of a vector is a scalar. If you add direction to it, there you go. You have a vector. Let's move this out of the way. Oops, there goes Wrong Way Corrigan, the wrong way. So let's talk about your average 12-year-old baseball pitcher. This player's pitching speed is about 55 miles per hour. Okay? However, if you put this guy in the back of a pickup truck, and the truck itself is traveling at 25 miles per hour, if he throws the ball forward in the direction the truck is going, the ball will actually be traveling at a speed of 80 miles per hour to the right. You can add vectors. We add these two because they're going in the same direction. However, if the truck is headed in the opposite direction, we're going to wind up subtracting the vectors because they're going in opposite directions, directly opposite directions. So the ball will only be traveling at 30 miles per hour to the right. In this case, the ball is being thrown to the right, but the truck is headed to the left. They're headed in different directions, so we subtract the vectors from each other. Previously, the truck was moving at 80 miles per hour to the right because both the ball and the truck were headed in the same direction, and we can add their vectors. Once again, direction matters. So if I told you that Owego is 20 miles from campus, what should your question be? I hope you ask, in what direction? If I told you to walk 3 blocks and then 5 blocks from your current location to get to the deli, could you do it? No, I didn't tell you which way to turn at any point. So we often need vectors, not just scalars. All right, have any of you ever done an activity called orienteering? Orienteering is a race that is done usually over kind of rough terrain. You're given a map and a compass, and there are various flags marked on the map where you usually punch a card, or now they do it electronically, give you some way to show that you have made it to each flag, and your time is recorded. Now, if I were headed from this blue X here toward that flag, I could go through this swamp. But I don't know, ticks, leeches, just taking the time slopping through the muck, that might not be the best direction to head in. So instead, you might decide that it's in your best interest to go around. Okay, so head east, say, and then head north. Okay, so that would be a vector in the eastern direction. Okay, you would be heading in that direction at a certain speed, and then you would be heading in this direction at a certain speed. And let's just say that north is up on this page. So you'd head east and then north. And adding those two together, you would still get to the same place you would have reached if you had gone straight through the swamp. But you'll arrive there cleaner and probably safer. So let's imagine that cutting straight through the swamp would be a distance of 400 yards. But if you head east first for 400 yards, and then you head north for 300 yards, you would reach the same point. 400 yards east, 400 yards north. Notice in each case, you have a magnitude and a direction. A magnitude and a direction. Here we have a magnitude, and I could have written a direction of toward the flag. Or I could have written a direction of northeast, but it's not exactly northeast. There is some angle here, and we're going to be talking about how you can find that angle. The point I wanted to make with this diagram, though, is that we can add the eastern vector and the northern vector to get to where we want to go. All right, let's get rid of this. The example that won't die. To recap, a scalar has magnitude only, or what we could call scale, thus the name, whereas a vector has magnitude and direction. Speed is an example of a scalar. If you add direction to it, you have a velocity. Distance is another example of a scalar, but if you add a direction to it, you have displacement. So a distance and a direction from the original position. And mass is also a scalar. If you accelerate that mass in a certain direction, you have a force. We represent scalars and vectors with different types of symbols, and these differ depending on which field or which class you are in at school. So let's just pick some letters here. You can have lowercase, you can have uppercase, you can have Greek letters symbolizing these different scalars. Now, if you also have a direction with these, you would then indicate that with an arrow on the top. The arrow does not need to indicate which direction necessarily, just that is the symbol that we use when we're talking about vectors. Most of the time, your units do not change between scalars and vectors. For instance, speed might be expressed in feet per second, and velocity would also be feet per second, and only you would add a direction to it, such as northeast. Distance might be in centimeters, but displacement might be centimeters to the right. Okay? Mass and force are a little bit different. Mass is often expressed in kilograms. Force, however, is expressed in kilogram meters per second squared, or newtons. But we also need a direction for this force. Let's consider the force of weight, as in your weight. How much do you weigh? So let's say the direction is down, or rather toward the center of the Earth, or toward the center of Moon, or toward the center of whatever large, massive object you are standing on. As a side note, the unit for mass in the English system, or the imperial system, is a slug. Yes, literally a slug. Whereas the force unit is a pound. You're very familiar with that when you step on the scale. In the US, your weight is usually reported in pounds. That is actually a vector. The acceleration due to gravity is actually producing that weight. Now, there are other things we can discuss about how pounds are used, but you know what? This is not a physics class. Let's get back to the mathematical ways to deal with vectors. And now it's time to play Is It a Vector? Remember, a vector must have magnitude and direction. All right, so for the first one, winds at 25 miles per hour from the north. Sounds like a small craft warning is needed. There's a magnitude. There's a direction. Yep, it's a vector. A bullet hits a wall at 400 feet per second. Magnitude, where's the direction? Now, if it said hits a wall perpendicularly at 400 feet per second, or at a right angle, okay, then we could say yes. But that's not there, so we have to say no. There's only magnitude. All right, a quarterback throws the ball 9 yards. Well, there's magnitude. Where's the direction? Maybe he didn't throw it downfield. Maybe he threw a lateral. Nope, no direction. Not a vector. The sun rises in the east. Okay, there's a direction. And the magnitude is not there. You need magnitude and direction. The next video in today's series will discuss how to actually add vectors graphically and mathematically. So go find the next video.